This was an experiment with starting starting an aquarium really bare bones. I just had tap water in here and duckweed on top, and there was nothing else in there. There was no rock, no wood, no substrate or soil of any kind. It was just tap water, and I threw some duckweed plant on top. And I did dose it with phosphorus and potassium. One of the two out of the three macronutrients that plants need, but not nitrogen, because I knew that duckweed was a nitrogen fixer. So it actually takes nitrogen out of the atmosphere that plants typically can't use unless they are nitrogen fixers and have like a symbiotic relationship with a certain kind of bacteria. So what happened was, after about 2 months, the duckweed grew and grew, and it would die, and it would fall to the bottom and create a layer of dead plant matter that would slowly decay. And it had the nutrients that it needed because it got the nitrogen from the nitrogen gas in the atmosphere, and it got the phosphorus and the potassium from the stuff that I put in the water. So it had everything it needed. So it grew and it died and it fell. And after a while, after a couple months, I had the components that I needed to build an ecosystem. I had organic matter on the bottom, which was going to decompose and release nutrients into the water that was really deficient in basically all the nutrients that plants need. Tap water is lacking all of them. I mean, it was untestable. The organic matter is also going to make CO2 for the plants. So now, whereas before I couldn't put plants in here at all because for one, there was no CO2 production, so they would just starve of CO2 and die. And two, they were missing nitrogen, a crucial macronutrient, which just wasn't in the tap water at all. But after a couple months, you had the organic matter, and which is going to provide the CO2 to the plants, and which was also going to provide a food source for bacteria and microbes and various other kind of organisms that I was planning on adding in here. But again, I couldn't do that until it built up. I did test the nitrate and the water now. At first it read 0 parts per million. Now if you look here, you can see that the nitrate level in the water is now about 30, between 20 and 40 parts per million, which is high, but it's workable. I'll just add some plants. You need to add plants because despite the fact that I have an oxygen tube in the back there, pumping air through to oxygenate the water, it's not going to do anything about the nutrients that are decomposing and being released, it's not going to do anything about the organic matter that's decomposing and releasing nutrients into the water, which will build up and create kind of toxic conditions for any organisms that I might want to put in there. So plants do have to go in. It's all part of the whole system that's all interconnected. That moss ball, just for looks, even though it doesn't look good, just a little bit of color in there, I guess. I tried to make it somewhat kind of interesting. The lava rock is, if you guys know about lava rock, it is extremely, it's got a very, very high surface area. So that added, probably 50 square feet of surface area. I bet you even more than that of surface area. That's going to give bacteria plenty of space to colonize, because when you're building an ecosystem, you kind of want to start at the ground level. It's like a house. You want to start at the base, and you want that base to be strong and robust and heavy, and a base to a small ecosystem like this is going to be the bacterial and microbiology component of the whole thing. So this just gives them plenty of room to do that. There's plenty of food for them. And if you have a healthy bacteria population going, it's going to ensure you're going to be able to support, the next trophic level up of organisms. Without the bacteria, everything is dependent on that. You're not going to be able to support anything that requires more energy than bacteria if you can't support bacteria. That just thermodynamically is impossible. But of course, before the bacteria, you have your primary producers. Without the duckweed, you wouldn't have any of this to begin with in the first place. So, anyway, the cool thing about this is I'll post some pictures. I took some water from my lake, Microcosm, which has lots of cool organisms in it. And I've already spotted some copepods and some hydra and some clam shrimp. What else did I see in there? Oh, planaria, which is a type of flatworm. Hydra and planaria are predators, but that's fine. We're trying to make an ecosystem, not a paradise. So anything that we can do to make it more like the regular ecosystem, the more beneficial it'll be, balance-wise, over the whole thing. So another cool thing about this is I don't have to feed this thing. I do half a cup, about a cup water change every day, because I don't want to disrupt the microbial balance, or scoop out too much of the really tiny organisms by doing a really large water change once a week. So I just do a small one every day to keep things more balanced that way. But of all those little organisms in there, most feed on that dead plant matter down there. So I don't have to feed this jar or this cube any food at all. There's nothing in here that I have to feed. So you might be asking, or I guess I should ask, you probably not, but I can ask, what do you think about the biomass of the stuff in this jar, this cube? Is it possible for the biomass of the organisms, for their population to increase, basically, if I'm not adding any matter to the cube? Because of course, where would that matter be coming from, right? You must be thinking. But the matter, the carbon, because we're all carbon based, so the biomass that we're made of, they usually call it the carbon content. The bacteria, the copepods, the hydra, all of those organisms in there, even the snails that are going to be around, the carbon that makes up them, they are getting that from the CO2 the duckweed is breathing in. It's all entering through the duckweed. This whole system has a lot to thank the duckweed for, because the duckweed essentially built the whole system. I put it together, but without the duckweed, there'd be nothing here to build upon. And the duckweed is what is adding nitrate to the water, a nutrient for the plants, and it's what's adding organic matter, which is kind of the food chain base of it all as well. So this little cube ecosystem is based entirely around the nitrogen fixation abilities of the duckweed, and the duckweed itself and its ability to produce the organic matter that supports the life within it. So yeah, this is a duckweed jar, duckweed cube. It's a very common plant. You see it all around in the lakes and stuff, but it has a very rare ability that not a lot of plants can do. So that is the jar. I think it's pretty cool. I'm going to be keeping my eye on it. I just kind of put the rocks and the wood and the moss balls in there today, so we'll see how it goes. I have no doubt it's going to be it's going to work just fine the way it is, because it's open with the water changes. It's going to be a nice, easy system to maintain. Nice and simple. Thanks for watching. Have a good day.